to this computer. Okay. Let's start this class. Today, we will finish talk about unit step and import functions, and then we will talk about the CT and DT systems. Yeah, and let's check today's goals. And firstly, we will review the import function and the sampling property, and then we will try to characterize the CT and DT systems mathematically, and then we will try to connect several systems into one system. Yeah, and firstly, let's try to review the CT unit import step and step functions. And firstly, let me ask you, what does CT unit import function look like? Yeah, and there is a arrow or dot. Yeah, arrow. Why? Yeah, the name, the value is not one, but the area is one. Yeah. Okay. And yeah, this is like a mathematical form for the CT unit import function. When the t not equal 0, it is always 0. If t equals 0, it is actually the value is infinite. But here the 1 is the area. Yeah. And how about the and the area we just did definition, like the integral, like the dt is just this width, and the theta t is just the height. Yeah, and then we just define it 1. Okay, how about the CT step function, DT unit import function? What does that look like? Yeah, that's right. It's just like that. Yeah, this one is easy to understand. It's the mathematical form is when n equals 0, it is 1. If n doesn't equal 0, it will like 0. Okay. How about the yeah, this is like a CT step function. Yeah, and this is the mathematic form. Yeah, when t greater and equal 0, it will be 1. Otherwise, it will be 0. That makes sense to you? Yeah, this is just some definition. And this is like dt step function. Yeah, when the n greater and equal 0, it will be 1. Otherwise, it will be 0. Yeah, just remember that. And let's review the relationship. Yeah, you can see the relationship. Let's try to recall how can we get the delta n using un, like how can we get the impulse function by unit step function? Do you remember? Yeah, like a difference. Yeah, this is un, this is un minus 1. n minus 1, which means right left, am I right? Right shift, and when you use this one minus this one, it's just like left the value here. That makes sense to you? Yeah. So which means the delta n equal un minus 1. Yeah, and then this is when you left, am I right? That makes sense to you? Yeah, and this after difference, and you can use the unit step function, get the unit import function. Okay, let's talk about how can you get a unit step function using unit import function. How? Huh? Accumulation, am I right? Yeah, that's true. Yeah, you can see this one. You can like using this equation. You can see here. Maybe you will have a question. Am I right? Like un, when n smaller than 0, it should be 0. Am I right? And if m from negative infinity to n But how, like then, how about the value? You can see here, what is the delta m? Delta m, which means delta m equal what? When m equals 0, it will be 1. Otherwise, like others, it will be 0, am I right? That makes sense to you? So which means m from negative infinity to n, only when m equal like 0, it will have value, am I right? Which means if n smaller than 0, this value, even you I can add all these value together, it is always 0. Does that make sense to you? Yeah. And if the n greater than 0, and if n greater and equal than 0, and this one equal, even there are so many values together, but only one value is 1. So the accumulator, after accumulator, it is the value, this is always 1. That makes sense to you? Yeah. So that's the reason why you can use this equation. Yeah, this is after like if n greater than 0, greater and equal than 0, and the value after you like accurate, it always 1. Right? Other value is just 0. That makes sense to you? Yeah. Okay. So after accumulation, you can use the impose function to get the step function, and after like that difference, you can use impose like a step function to get the impose function. Yeah, this is just like the opposite thing, like that. Any questions so far? Okay, and then let's try to review the DT sampling property. You can see here, if we have a signal xn and we have a delta n, and after we multiply those two together, what we can get? Yeah, only the value here, am I right? That makes sense to you? Because other value is just 0, am I right? After you multiple, and this value is just equal this thing, am I right? Yeah, and the similar thing for after you shift, if you use this one to multiply this one, like for example, n now here. For example, n now is here. Am I right? Let me give you a pen. Okay. For example, n now is here. Am I right? So which means you have this one. After you multiple this one and this one, you can get this value. Am I right? Yeah. So similar thing. You can get this here. You can have this one. Am I right? So only the n now, when the n now, when the n equal n now, you have that value. Otherwise, you have 0. That makes sense to you? Yeah, this property, we call it a sampling property. Why we call it sampling property? Because sampling, we know that it gets the specific value we want. Am I right? So this is just get the specific we want. That makes sense to you? Here we got when n equals 0. Here we got n when n equal n now. Am I right? And now you can have it any value. Am I right? Yeah. So this is DT sampling property. Okay. Let's talk about the CT unit step function. Like the CT unit step function is defined in a manner like its DT counterpart as this one. Yeah, when t greater or equal 0, it will be 1. Otherwise, it will be 0. Yeah, this is DT unit step function. And then this is this is CT, this is DT. You can compare. It's just like one is t and one is n. Am I right? Yeah. What is t here? T. What is t? What does t represent? Time. What does n represent? Yeah, time. What's the difference? What's the difference? Yeah, this is the difference. Yeah. Yeah, that's an integer, positive integer, like not only positive, like integer number. Does it make sense to you? Yeah. Okay. So let's talk about the CT unit impulse function. Yeah, this one is a little difficult to understand, but if you review the video, I have we talk about this in next class. when t not equal 0, it is always 0. When t equals 0, actually the value here is infinite. But the 1 here is just the area. We define the one forward rectangle. What is the area? The area is W multiple height, am I right? Like Y is multiple height, am I right? And we can consider here is like a rectangle. Yeah, the width is just dt, am I right? It's very small. And the like height is theta t, am I right? We just define this is 1. This is area like that. Yeah, that makes sense to you? Okay, and then this is like the CT unit step function. We can using this equation to, if we have the unit step function, we can using this equation to have the impulse function. Because we know if the slope is like this, after you derivative, it will be infinite. Yeah, I think you learn this in some mathematical class. Am I right? Like differentiation, ODE, maybe you will learn this. Yeah, when the like slope is just 0, like, am I right? Yeah, and then if you know this one, and if you want to get this one, you just integral that. Yeah, because you can see t here, it will be 1, 1, 1, 1, 1. That makes sense to you? Yeah. Any questions so far? Yeah. Okay. And for the CT sampling property, actually it's similar with DT. Yeah, you can see here. This is the delta t, like the input CT impulse function, unit impulse function. This is the xt, any signal here. And then after you multiple those two together, what you can get? Am I right? Yeah, you can get this one. Yeah, this is just the area, like the value here must be the area. Am I right? That makes sense to you? Yeah. Okay, you can get this one. You can get it because the other value is 0, right? Only here has value. But the value here is infinite, which means you using this value multiple infinite, am I right? That makes sense to you? Yeah. Okay. And then similar with this one, it's just a shift. Yeah, it will delta t minus t0. For example, this is t0, which means you can get this value here. That makes sense to you? Yeah. Okay. So this is like a sampling property. Let us review some examples. Like for the CT example, here is a CT signals xt, and then we want to use this like impulse function to simulate this one, and then let's try to use the equation we have already learned. So for this equation, negative x negative t multiple t plus 1 plus. Let's try to, because here there are 2 atoms, am I right? So let's try to multiple this atom into the parallel space. Yeah, what will it be? It will be x. Am I right? Yeah, because you just put this part into paradise. Am I right? Yeah, it will equal this one. That makes sense to you? Yeah, and then you can see here, when, which means let's using this equation here. So here, what is T now here? Yeah, because we need to use this equation, right? So what is T now? Firstly, 0.5, we just put it here because it will not change, right? Yeah, let's using that equation to calculate this part. What is T now here? T now equal, are you sure? T now equal 1? Huh? Like here, T now is T minus T now, right? Here is T plus 1. What does it mean? The T now equal what? The negative T now equal 1, right? at least t naught equal what? Yeah, -1, am I right? So which means here, x here, the t naught. T naught equal -1, am I right? Here it should be t should be t naught, am I right? So which means here should be 1. Because here we should put this is x negative t. We should put t should replace t with t naught, am I right? So t naught equal -1, am I right? So this one should be x1, am I right? That makes sense to you. Then other things we keep the same, am I right? Yeah, since that then this part. Okay. What is t naught here? Yeah. And what is here? What's this? Yeah, that's true. Yeah. Okay. Let me see if I just. Oh, sorry. Here is. Yeah. Sorry. Yeah. Yeah. So what's the t naught? I just t naught was 1. Am I right? So here. So this here is -1. That makes sense to you. So then we have this one, right? Yeah, that makes sense to you. So what is x1 here? Yeah, we have xt, right? What is x1? Huh? 1, am I right? So we can put 1 here, am I right? And what is x -1? 2. So 2 like a multiple is 1, am I right? So we just yeah, we can get this one. That makes sense to you. This is the signal we finally get. Yeah. Also, you can use this the shift we talk about. And here, firstly, let's get this part. -0.5x -t. The x we have xt, am I right? How about how can we get x -t? It is what? Reversal, am I right? Reversal, what does that mean? Just flip based on this one, am I right? And then here, this -5 is just like put it half. Does this make sense to you? Am I right? And then here is a negative, which means it's just like flip based on the t. Yeah, I think here, yeah. This is the -0.5x -t. Does it make sense to you? And then this is negative delta t plus 1. And this is plus -t minus 1. Because when t equal 1, it will be 1. All right? When t equal -1, it will be -1. Yeah, because there is a negative. Does it make sense to you? Yeah, this is this signal. After you multiply this signal, what you can get? Yeah, you can get this value, am I right? And this value. This value is -1, so you just flip it. You can get this one, am I right? Yeah, but you can see it's just exactly what we got here. When t equal -1, it will be half, am I right? When t equal 1, it will be 1. And it will be -1. Here is the negative. Yeah, you can use the shift and after shift and multiple together. Use this equation. Also, you can use the equation we talk about here. Here, yeah, that makes sense to you. Yeah, you can easily to get. Any questions so far? Okay, this is CT, like a sampling exam. Okay, let's talk about the other DT exam. This is a DT signal, and then we use this equation. We want to get this signal, and what we can do? Actually, we can use the equation we talk about it here. Am I right? The similar thing. Yeah, I will leave it to you. And then we also can use the image, the figure thing. Yeah, this is if you want to get this equation, what do you have? What's the first step? Shift, I'm right. Yeah, and then like scaling and all the inverse, like a reversal, I'm right. Yeah, but you also, like I said, you can get this equation when n is equal 1. What the value in the for this part? When n equal 1 for this one, for this signal, what is the whole value for this part? -1. What is the value? Wait. Oh, sorry. Here is 0. Here is 0. Yeah, when n equals 0, what is the value for this part? 1. What's the value for 1? Huh? What is the value for 1? It is what? What is x1? Yeah, 1. I'm right. So that's the reason why here is 1. How about the 1? We talk about 1 just now. If n is 1, this part is x negative 1. I'm right. What's the value for x negative 1? 2. Yeah. And then if n is 2, what's the value here? Huh? If it is 2, n is 2, -3, am I right? What is -3 value? Yeah, 1. Yeah, and then using the similar equation, if it is a -1, here is 4, x4, am I right? The x4 equal what? 0, am I right? Yeah. X4 equal 0, so which means there is no value. Does it make sense to you? So, and then this is delta x n plus 1 is this one, am I right? Yeah, because which means n equal -1, it is 1. Otherwise, it will be 0, am I right? There is a positive, so it is this one. And here, when n equal 1, it will be 1, am I right? But here is a negative, so you need to flip it like this. Does it make sense to you? So then you multiply them together, which means you can get this equation. Does it make sense to you? Because 1 by 1 is 1. Like 2 by -1 is -2. Am I right? Does it make sense to you? Any questions? Any questions so far? And then you can get this signals using this method, figure method. But also you can get using this method to get this thing. Yeah. Any questions so far? Yeah, you can see you put those two together, which means when n equal -1, it will be like 0. It will be 1. Otherwise, it will be 0. And when n equal -1, how many? What is this value? 3. Am I right? So x3 equal 1. So it's just 1. And then similar with this part. That makes sense to you. Then you can get this one. And this one you can see it's just exactly this thing, this figure. Yeah, here when n equal -1, it will be 1. When n equal 1, it will be this value is 1. Then multiple -2, it will be 2. It is 1. Oh, this is 1. Multiple -2, it will be -2. That makes sense to you? Yeah, this is just exactly this one. Yeah, so which means you can use 2 different methods to get these signals. One is just draw the figure and try to multiply 2 different figures. And the other is just use the equation we talk about. That makes sense to you? Yeah. Okay. This is the like DT, CT, unit, step, and impulse functions. Those functions are very useful when we deal with some signals. And then let's wrap up those things. And for those 2 different functions, the property is very important. is a very important property for us. Yeah, it is very useful, and we will talk about it in the following classes. And then let's begin to talk about CT and DT systems. Okay, actually, we talk about systems in the first class, am I right? Yeah, what is system? What is system? Huh? Yeah. It get input and try to give output. Am I right? So the system allow us to analyze, process, and manipulate the signals according to our needs. Which means, we have signals, and we try to analyze it, process it, manipulate the signals, and then try to output the specific signals we want. That makes sense to you? Yeah, and we can use these figures to represent it. Yeah, this is for the CT system, and for the CT system, we just get the continuous input, and after we deal with it, after we analyze, process, and manipulate, and we can output continuous signals, the other continuous signals. That makes sense to you? Yeah, this is the CT system. And how about the DT? DT system, similar thing. Am I right? Yeah, only the input and output is changed. Like for the DT system, our input is a discrete signal, and the output is discrete signals. The other discrete signal. Does that make sense to you? Yeah. Okay. Let's try to analyze, try to find the difference between signals and systems. Okay. Before we talk about this and what's systems and what's signals, like based on what we have already talking about. What is signal? What is a signal? Yeah, wave. Yeah, you're right. Yeah, you're right. Well, wave. Yeah, that's a very good example. Actually, a signal is something that converts information about the state or behavior of a physical system. For example, speech signals, image, and you can see the wave. You can present the speech signals with a wave, and audio signals wave, and image, and some like some metric. Yeah, but it is just like the information. Am I right about this thing? Am I right about the state up here of a physical system? That makes sense to you? Like weather, like the temperature. Am I right? It is just like a physical system, and the signal is just something that converts the information. So for example, the wave. Yeah, and the like some this is also a signal. Am I right? Yeah. Okay. And what is a system? Yeah, system, we just talk about that. Like something that can manipulate, change, record, or transmit signals. For example, amplifier, mixer, and recorder, am I right? Microcontroller, PCW. Yeah, we can try to analyze, try to deal with this signal. Does it make sense to you? Yeah, okay. And then how to characterize them? Yeah, how? Do you have any ideas? Yeah, let's try. Let me tell you. A signal is characterized internal what content is contained in the signal. For example, a voice signal, a music signal, and a vital sound signals. Yeah, it can be characterized based on what content is included. Am I right? Because different signal maybe have different like mathematical form. That makes sense to you? Yeah. Okay. And then a system is characterized in terms of how it will modify an input signal to produce a corresponding output signal. For example, an audio mixer or a speed detector. Yeah. A system is characterized in terms of how it will modify an input signal to produce a corresponding output signal. There are two very important points. The first one is like a signal. Firstly, we need to characterize a signal. Like put a signal in like contain this signal should contain some signal, am I right? Should contain some like information. For example, the voice or music, am I right? Like we need to try to find a mathematical form to represent this signal, am I right? And then we try to find a mathematical form to try to deal with this signal, to try to modify this signal, and then let the signal, let the input signal transfer to the output signal. Am I right? That makes sense to you? Yeah, this is what we will learn in the following like classes. Okay, let's talk about one very easy system exam. Yeah, this is what is this? Actually, we talked about this system before. What is this? What's this? What's this? Huh? What's this? Resistor, am I right? What's this? Yeah, so this is a very famous name, RC circuit. Actually, we talked about this in this morning, RC circuit. Yeah, like the capacitor can what? Can charge and discharge, am I right? Yeah, so we can use, yeah, let's try to find the relationship between the input and output. Consider here, Vs is the input, the Vc is the output. And then actually, yeah, we have this equation. If you are familiar with electronics, yeah, the IT here, IT, which means the current through the like resistor, so, also this first equation, which means the current through the resistor, and the second like equation is the current through the capacitor. Actually, those two current are equal. That makes sense to you? Yeah, because this is the same current. Am I right? Any questions so far? Yeah, and then those two should equal, so we can have this equation. That makes sense to you? Am I right? And so then we have this equation. You just put because we want to find the Vs and the Vc, so we put Vs in one direction, the other the Vc in the other direction, and then put the Rc here and put the Vc here. And then we have this equation. Yeah. So any questions so far? Yeah. And then we just make a little difference. Try to put this one with this one. Yeah, just try to move RC from here, then to here and here. Yeah, we can get this one. That makes sense to you? Yeah, this VC is just like the output, and the VS is the input. So we find the relationship between the input and output. That makes sense to you? Yeah, and then let's talk about the other system. The like automobile, like this automobile like system. Yeah, actually, let's find the input. The input is the force we give the like this automobile, and then the output is just the like velocity. That makes sense to you? Yeah, we give it a force, and then the car will run. I'm right in the specific velocity. That makes sense to you? And the equation should be like this. Yeah, the force more minus this is just this opposite force. And then using this equation, you can get the velocity. Yeah, if you learn some physical class, you will know this one. Yeah, our important thing is now here. Yeah, let's talk about after you multiple the m into the parentheses and then put the this part in this set, and you can get this equation. Am I right? That makes sense to you? Yeah, and then. Remember the RC circuit we just talked about. Yeah, and we have this equation. Yeah. So compare this one and this one. What you can find? What you can find? Yeah, this is the input, am I right? For this system. This is the output for this system, am I right? This is the input for the RC circuit, and this is the output for the RC circuit. Can you find the similar thing. Yeah, you can see the form is very similar, am I right? Yeah. So we can represent this form to represent that two system. DYPD, because this is the output and this is the output, this is the input. Yeah, is that right? Yeah, we can use this equation to represent these two systems. The A and the B is just some constant thing. Am I right? Yeah, because for different like system, the RC for the RC circuit, the RC is constant. For the force, this car force system, the rho and R is constant. That makes sense to you? Yeah, we can use this equation to represent this one. Am I right? Yeah, what does that mean? What does that mean? Actually, there is a conclusion. Like all first order, you can see this is the first order. There is no power. Am I right? All first order linear time invariant system can be represented in this form. Yeah, we will talk about later. Yeah, but you can remember. Yeah, all the first order linear like invariant system can be represented as in this form. Yeah, that's when you try to analyze your maybe robot or something. If your like equation is just a first order linear system, you can use the method we will talk about to analyze this system. Okay, any questions so far? No? Okay. Let's talk about the DT system exam. Yeah, consider a simple model for the balancing a bank account from month to month. Yeah, this Y is the balancing a bank account from month to month, like the total amount. Yeah, and then XN is the net deposit during the nth month. Yeah, this is just the what is the X, what is the N. Then the X, the monthly interest rate is 1%. And this is the equation, if we want to represent find the relationship between the input and output. Yeah, this is just like a XN. Yeah, this is just like the total amount you have already had, right? Here is just like after this month you have this interest, right? And the original and the interest, and this is like the new money you deposit, and this is the new total amount. That makes sense to you? Yeah, this is easy to understand. And then you can see here, you can put this atom in this step, and you can get this one. Yeah, this is your input, and this is your output. That makes sense to you? Yeah, this is the next month's amount, and this is this month's amount. This is this month's new like deposit. That makes sense to you? Any questions so far? Okay. And then let's try to compare the CT system and the DT system. You can see this is the first order differential equation. We know for all the first order systems, we can use this equation to represent it. Not only for RC circuit and that automobile force system, we can use this equation to represent all the first order linear invariant system. Yeah, we will learn what is a LTI system later. And then this is the first order difference equation for the DT system. Okay, let's what's the difference? What's did you find the similarity? Do you find the similarity? Do you? Yeah, you can see here, this is input, this is the input, and there is a coefficient, constant coefficient, there is a constant coefficient, am I right? And this is output, this is also the output, am I right? And this is this is a NASA month, this is this month, like the NASA time, this is this time. And the only difference is this here, am I right? And it has difference, and also it has a similarity, am I right? Yeah, and we have this conclusion. All CT-DT systems can be written as constant coefficient differential or difference equations are linear time invariant LIT systems. Yeah, well, actually, if you remember our course map road, the LIT system is the chapter 2's name. It's just a LIT system. We will we will learn what is LIT and how to deal with these systems. Yeah, but you just remember all the CTDT system that can be written as constant. If you can write your CTDT system in this form, and then those system is a linear time invariant system. Yeah. Any questions so far? Okay. Let's try to see an example. Like here, there are two different systems, S1 and S2. And S1, we can write this equation for that one. It is equal, here x1 is just like the input for system 1. And then the S2, it's just the x2 is the input for the S2, and the y2 is the output for the S2. So what is the difference? Okay, wait for a moment. Oh, sorry, I should show this. Yeah. And what's the difference equation of the whole system? Yeah, you can see this is the input, am I right? And those input goes here and goes here. And we consider this is x1n, this is x2n, and this is the output, y1n and y2n. And this system I have already give you. After go through this system, the input will become, the output becomes this one. The relationship between input and output is this one. And go through the system 2, and the relationship between input and output is this one. So what is the difference? Like this symbol is just a plus, add. So what's the whole system output? You can see, we know the y1 should equal y1n plus y2n, am I right? Because here, this is adder. That makes sense to you? And what is y1n? I have already given you, am I right? Here. And y1n and y2n, I have already given you, am I right? And then we know xn equal xyn equal x2n. Yeah, any questions so far? Here. Yeah, we know xyn and x2n equal xn. Here. Yeah. Any question about this thing? Yeah, because you can see the xn just go to different branch, am I right? But it's the same. So then we can get this one, because you put xn here, xn here, xn here, xn here, you can get this one. That makes sense to you? Yeah, this is just the whole system. Any questions so far? Okay, and then let's talk about the other one. This system, there are two different systems, and the input goes through system 1 firstly, and then go to system 2 secondly. And then let's talk about what is the whole system, what is the difference equation of whole system. Okay, yeah, this is and why we know y2n equal this one, am I right? What is x2n? x2n is what? y1n, am I right? That makes sense to you, because here I just consider this output as my input. So x2n equal x1n, am I right? So you just use y1n to replace x2n. That makes sense to you? Am I right? So what is x1n, xyn, x1n is this one, am I right? That makes sense to you? Yeah, so you just put y1n plus 2, right, using this equation, and y1n plus minus 3 using this equation. Does it make sense to you? It will equal this one. Any question? Yeah, because you can see, if I want to get the y2n, what's my input? My input is x2n, am I right? And the x2n equal y1n, am I right? So this is my y2n, and I just replace x2n with y1n, am I right? Because the y1n equal x2n. And what is y1n? Y1n is this one. Am I right? That makes sense to you? So I just try to use xy to represent y1. Any questions so far? And then I can get this equation. Okay, sorry, I can get this equation. That makes sense to you? Yeah, let me try to this. Oh yeah, we have. Here, what's our question? Our question just want us to calculate y2 and am I right? Am I right? Yeah, this is like a final output. Y2 equal what? X2 plus X2 minus 3. Am I right? And we know X2 equal Y1. Am I right? Yeah, this you know that, right? I just consider like your output, the first your output as my input. Am I right? That makes sense to you? So which means x2n equal y1, which means x2 n plus 1 n minus 1 equal y1 n minus 1. Like n plus 1 equal n plus 1. Whatever here, you just change here, am I right? That makes sense to you, which means it's just a y1 n minus 2 plus y1 n minus 3. Am I right? Yeah, this is easy to understand. And then we know like the y1 equal what? Like 2xy plus 4xy minus 1. Am I right? So which means if I use n minus 2, replace n, I will change this to n minus 2, change this to n minus 2 minus 1, right? So I can get this. I can get this part. Okay, sorry, this part, am I right? And then if I use n minus 3 to replace n, here is n minus 3, and here is n minus 3 minus 1. Am I right? So this is this part. That makes sense to you? Yeah. And then I can finally, oh, sorry. Oh, I can finally, just because here, x1 equal xn, am I right? Just the input. So I just try to here is n minus 3, n minus 3. These two can be together. That makes sense to you? Those two can be together, right? So you can get this one. Just put it here. Put those two here. Put this one here. Am I right? Yes. Here is a half. That makes sense to you? Yeah. Any questions so far? Okay. So let me ask you: will changing the order of S1 and S2 change the result? After you change this order, put S2 here, S1 here. Will it change? The final result will be changed. Huh? It will not, no problem. It will not. This is, yeah, because you can see this is just a linear invariant system. So it will, after you change the order, it will now change the your final result. Yeah, this is our homework. Yeah. Did you start the homework? Yeah. Yeah. That's because you just put it in, you just started. No, you need to start after start the homework after every class. Yeah, you can see after every class it's just a 2 or 3 questions. Yeah. Yeah, that's the reason I give you that tips. That makes sense to you. Yeah, but I give you the answer. Yeah, you try to find how to get that answer. If you have any questions, just let me know. Find me in the office hour or just make an appointment with me. Is that okay? Yeah, and I tell you all the midterm questions is from from homework. Yeah, if you finish the homework and you can, yeah. Okay, any questions so far? Okay.